Hello and welcome to the video. In this video we're going to be a little bit technical today. We're going to talk about Ohm's law and calculating the values of things like resistors in series with LEDs so that you can add an LED to any model that you're interested in. Now this was something that was asked by Stephen in the videos that I did last month where I asked for ideas for video, and Stephen asked specifically about how to calculate resistors, Ohm's law, do's and don'ts and night flying, and rather than do lots and lots of videos, what I'm going to do is cover it at a reasonably high level in this video here. So hopefully Stephen, by watching this you'll get the answer to your question and know enough to be able to crack on and add LEDs to any model that you're interested in. Now the really nice thing about LEDs is that they're very efficient in turning electrical energy into light. So rather than the filament bulbs that we used to use in our cars, then the LED uses a very small amount of power, 20 milliamps or 20,000th of an amp, to light up and to shine. Another nice thing as well is it needs a very low voltage to do that with, and average values are about 1.8 volts. But because the majority of the systems that you're connecting a LED 2 are much more than 1.8 volts. So in a remote control model we'll have a 5 volt system, a 12 volt system. We might be running a 4, 5 or 6S battery, so we can have 16 to 20 odd amps in the flight battery as well. That's much more than 1.8 volts that the LED needs to light up and be safe. So you need a way to get rid of that excess voltage, and that is what the resistor is for. And the resistor is also there to limit the current that goes through to that 20 milliamps that the LED needs so it lights up safely. Now you can easily calculate what that resistor needs to be, and we're going to talk about that in this video. But we're not talking about the LED strips that we've been using so far in the series. Those LED strips are either designed for 12 volts, so you just plug them onto a 3S power supply, or some of them, like the ones that are individually addressable, originally designed to work with the Arduino system, they're designed for 5 volts too. Now one of the reasons that you can do that is if you looked on those little strips, you'd notice that the little boxes beside the LED chips in the strips themselves, they are actually the little tiny resistors that are there to do this job, to get rid of any excess voltage, but also to limit the current that's going through the LED as well, to make sure that it lights up safely. So if you already got an LED that's rated for 5 or 12 volts or something else, you don't need to worry about this. You can completely ignore the video. But if you want to go out and buy LEDs from your local electronics shop or get them in a bag from somewhere like eBay, and you want to add them into the tips of the wings and put them as navigation lights and wire them in yourself, then by watching this video you'll know how to calculate the resistor voltage so that you can figure all that out and get all those LEDs to light. There are actually 3 things that we need to know in order to calculate the value of a resistor and to wire everything up with our LEDs and get them to light okay. The first 2 things are specifications for the LED itself. Now the forward voltage and the current that it needs is usually in the datasheet that goes along with the LEDs. The default values that I always work with if I can't find a datasheet are 1.8 volts for the forward voltage and 20 milliamps for the current, and that usually works pretty much out of the time. 20 milliamps for the forward current will give you a nice bright LED. You can run LEDs at less than that, so an LED will light with kind of 10-15 milliamps, but for full brightness 20 milliamps is a nice value. For this particular LED that we're going to pretend to wire up, here's the datasheet in the bottom right hand corner. You can see here that the forward voltage on this one, for the super bright red LED I'm interested in, the forward voltage is actually 1.85 volts, and that forward current is absolutely what I'd expect to see, which is 20 milliamps. The only other thing I need to know is what the voltage is that I'm going to be connecting the LED into. Am I going to be connecting it into a 5 volt system on the plane or the model? Am I going to be connecting it directly to the battery? What am I going to be doing? Once we know those 3 things, we can work out the value of the resistor with some very simple maths and good old Ohm's law. So here's the circuit ready for us to add the resistor in. So we've got the symbol for the LED in the top right hand corner. So an LED stands for a light emitting diode. That symbol there without the little arrows shooting out the top is for a diode, but the fact it has the little arrows down there shows it's an LED. And the way you connect it is, if you have a physical LED in your hand, you'll notice that one of the leads is slightly shorter. That's the cathode that needs to be connected to the negative side of the battery, and the other side is the anode, which is the positive lead, usually longer, and that is the one that you need to connect to the positive terminal of the battery. But because we're about to connect this to a battery that has far more than 1.85 volts, we need to figure out what that resistor looks like. So let's assume we're going to use a 12 volt battery here. We need to figure out what the value of the resistor in series with the LED needs to be in order to get rid of that excess voltage and also to limit the current to the right amount as well. So we're going to use Ohm's law. Now, I'm not going to go into too much detail about Ohm's law. It's one of the basic principles of electronics, and if you are doing anything with electronics, you'll be using Ohm's law on a very, very regular basis. But the Ohm's law is the relationship between voltage, amperage or current, and resistance in wires and pieces as well. So this is how they all go together, and dividing voltage by the amperage will give you the resistance. So we're going to use Ohm's law to figure this out. So what we have to do is to drop all of the voltage that the LED doesn't need. The LED again needs 1.85 volts. The battery is going to supply 12 volts, so we need it to get rid of the difference, and we need to divide that by the amperage we want to go through the resistor, and that amperage is going through the LED as well, and we know that's going to be 20 milliamps, or 20 thousandths of an amp, or 0.02 amps. That's what 20 milliamps look like if you write it as an amp. So we're going to divide 10.15 volts by 0.02 amps, and that tells us that the value of resistor we need is about 507.5 ohms. So we need to get a resistor that's there or thereabout. Now, you typically can't get exactly the value of the resistor, so I tend to look at the resistors that are available and get one that's close enough. On the power levels that we're talking about here, we can use reasonably small resistors. We're not dissipating tons and tons of power here, so you can get away with the really small dinky ones. If you think about the size of the resistors that are inside the individual packages that we looked at the start, those are kind of surface mount resistors. So the discrete resistors with the little coloured bands around the outside will be fine for this kind of stuff. And what I tend to do is just buy a big bag of them from eBay. They're not particularly expensive, and then I can kind of fish around and find the resistor that I need. So this time what we're going to do is we're going to connect LEDs in series. Now, I like connecting LEDs this way. So the cathode, or the negative connection of the LED, goes into the positive connection of the next LED, and you're daisy chaining them together, just like in the picture. Now, this way round, the way it's going to work here is the 20 milliamps current is going to flow around the circuit. It's going to go through the resistor at the top, it's going to go through the LED at the top, carry on round the bottom, and it's also going to go through the LED at the bottom as well. So we can actually get that 20 milliamps from the battery to do a little bit more work by flowing through each of the LEDs together. But because we're connecting these LEDs in series, we actually need to get rid of a little bit less voltage in the resistor, because we're going to need 1.8 volts that one LED is going to drop across it, and the second LED is going to drop another 1.85 volts. So this time we're going to need to find the resistor that's going to get rid of the difference between the 12 volt battery and the 3.7 volts that the two LEDs will drop across themselves, and we're going to divide it by 0.02 amps, or 20 milliamps again, because again we've got that 20 milliamps is going to go through both of the LEDs, and actually we're going to be able to get two lots of work out of it, which is good. So this time we're going to divide 8.3 volts by 0.02 amps, and this time the resistor is a little bit smaller. It's 415 ohms rather than the 500 odd that we had in the last example. But I like connecting LEDs like this, so with one lot of 20 milliamps from the battery, I can light up several LEDs at once. So let's go crazy. Let's actually add 3 LEDs onto the same circuit. Same thing applies here. We have the same 20 milliamps running through the system. This time though, we've changed the battery to be 16 volts. So this is probably going to be a 4S LiPo, and what we're going to do is we're going to figure out what the resistor needs to be. Now each of these LEDs again is going to drop 1.85 volts across, so we need to have 20 milliamps flowing through all three, and then we need to figure out what 3 times 1.85 volts for the LED voltage needs to be, and we need to drop the rest in the resistor. So this time we're going to take away 5.55 volts, which is the 3 times 1.85 volts for the 3 LEDs, away from the battery voltage, which is 16 volts. And again, we're going to divide it by 0.02 amps. We're still going to use that same 20 milliamps flowing through the circuit to actually light these things all up. So this time we're going to divide 10.45 by 0.02 amps, and again we're getting 522.5 ohms. A very, very similar value to all the ones we've already had. But this way you can have many LEDs in a string, essentially, running from the battery and using one lot of current and power. So that's talking a lot about connecting them in series. There is also the option to connect them in parallel as well. So what do we do in this example? So here, rather than have the LEDs connected in series where one is kind of connected to the back of the next one, this time we're going to connect them in parallel. Now again, we're going to use the same 16 volt battery that we just had in the last example, but this time the way it's going to work is we're going to have 20 milliamps flowing through the first LED on the left, and we're going to have another 20 milliamps flowing through the LED on the right. And that means through the resistor we're going to actually have to have 40 milliamps, because that will split up once it gets through the resistor and go through each of the LEDs. But because the LEDs are mounted in parallel, we only need to drop 1.85 volts. Because we've connected all the anodes together and all the cathodes together, and one LED would drop 1.85 volts, doesn't matter how many we put by the side of it, that's not going to change. So this time, to figure out the resistor value, we need to take 16 volts minus 1.85 volts. So the 1.85 volts is the voltage across the LEDs, and because they're in parallel, it's only 1.85. 16 volts is the battery voltage, and this time we're going to have to divide it by 0.04 amps, because again we need 40 milliamps flowing through the resistor so it can split up, and 20 can go into one LED, 20 can go through the other. So this time we're going to divide 14.15 volts by 0.04 amps to get the resistor value. So Stephen, hopefully that helps a little bit here on what you need to do. So first of all, find out the forward voltage for the LEDs you're interested in. Figure out the current that they're going to need. They're usually going to be in the values of about 1.8 volts and 20 milliamps. Figure out how you want to wire them together. I'd recommend, if you're going to put them on a 12 or 16 volt battery and connecting them directly to the flight battery, which is the way that I would do it for something like this, I would put them all together in series and then just use one lot of 20 milliamps to run the entire thing. Another consideration is putting a little switch in series with these things as well. That does mean that if you're flying in the daytime and you don't want your lights lit, or you're working in the workshop or trying to take photos or whatever, you can turn them off too. Another option is to wire them up to the balance connector onto the battery. Because these things are running so little current, the balance tap will easily provide that level of current without having a problem, and it does mean that you can plug in the main battery connector, the XT60, the Deans, or whatever you're using to power the model and fly, and in those instances where you want to night fly, you can actually connect the balance tap onto the balance connector on your battery and have your model lit up too. We have also looked at remote control switches so you can turn the lights on and off, and I'll put a link here in the top right hand corner if you're interested in going have a look at that. But hopefully now you can go and buy LEDs from anywhere and add them to any voltage on your model and get them to work. Thank you for taking the time to watch that video, and particularly for watching right to the very end. We try and release a video on Tuesday and Friday, and sometimes we'll release 1 or 2 extra ones in a week as well. All of the videos on the channel are organised into easy to use playlists, so do have a look in there, because if you're interested in a subject, we organise all the videos on that subject so you can find them easily all together in one place. If you like what we're doing, then please like and subscribe and tell others about the channel so they can come and join as well. We're available in all of the usual social media places, particularly in places like Instagram, Twitter, and we also share all of our 3D designs on Thingiverse.